quantum particles act as both particles and waves. We're going to talk about waves in the future. So if you're like, I still don't really get that, just chill. This is just a little summary. A particle is a single point in space. Easy to picture. Just like a little dot, okay? A wave is the opposite. A wave is all points in space. Water is like a massive wave because it spreads everywhere. A wave is all points in space. So it's the complete opposite from what a particle is. And all quantum particles are all waves in all points of space. This is very important, right? So if all quantum particles can act as particles and waves, all quantum particles and all matter, at minimum matter, let alone everything else going on. Matter is made up of atoms, which are made up of quantum particles. And other stuff, like non-matter, is made up of quantum particles. And all quantum particles can also be waves, which are all waves in all of space. Do you see the importance of this statement? That means these quantum particles are all everywhere, all of the time. A field in math and physics is an energy, but an energy is too strong of a word. It's just like a thing that takes up every point in space. That's what we call a field in math. It's something that takes up every point in space. Therefore, we can conclude a wave and a field are the same thing. They mean the same exact thing. So our reality is made of fields, okay? Our reality is made of fields. We already concluded our reality is made of waves. Wave equals field. Therefore, our reality is made of fields. And particles are simply fluctuations in that field. Quantum field theory. Not only is everything a field, everything is a wave, but particles are simply a pop-up aspect of that field. A particle is simply a temporary, localized thing that pops up and then goes away eventually. It's when you saw in the video that rippling, that grid, and it was rippling, those spikes and dips are simply particles. And then you notice they change and they change and they change and they change. The electrons on the, now there's an electron, now there's not, there's an electron, there's not, you know? It's changing. Particles are simply excitements in the quantum field. They're simply ripples in the quantum field. Quantum physicists call this field quantum foam because it looks like foam, the way it's just constantly bubbling. And it is also called 0-point energy. When they mention that they had that box and they're like, what if you took out all the light and the kinetic energy, whatever he said they took out everything, and he's like, then you get a vacuum energy that looks like this. That is also called 0-point energy because it's supposed to be the energy in a zero state. Like when there's nothing else, there's zero else. There's supposed to be zero happening, but we still see these quantum fluctuations. This is proof that there is this energy field working on us all of the time. And it has all of the information of all of the time because energy can be neither created nor destroyed. So the 0-point field. I know this is a lot, and this is why I'm breaking this up into parts, because this doesn't even scratch the surface of like everything else that goes on in the quantum world, but I'm so excited to be sharing this science with you. So also in my course, Unlock the Universe, we talk a lot more about the 0-point field specifically, but I still obviously want to touch on it here in this conversation because it's so important. So the 0-point field is made up of 0-point energy, ZPE, and it is the energy left when all other energies are removed. We can't reach zero motion in 0 kelvins because it will violate Heisenberg's uncertainty principle. Okay, so Heisenberg's uncertainty principle is something we will talk about later in the presentation, but basically what Heisenberg's uncertainty principle says is you can't know two aspects of a quantum particle at the same time.